All right, guys, I'm going to go over this quick little lecture here. This is going to be a short one, and I'm doing this a little bit different because I need for you guys to have a little bit different information. That's what I was talking about. A lot of things written down here, or a lot of things that aren't written down here that we need to really discuss. And so I'm not going to go very far. I'm only going to do 2 slides today, but there's some extra stuff for you guys to actually answer on. This PowerPoint is going to come from me, so you're answering your own words as I speak through this all, okay? So basically, we're looking at the respiratory system. We got the upper and lower respiratory system parts, okay, sinus, nasal pharynx, oral and nasal and oral pharynx, the epiglottis, larynx, the trachea, down into the lower respiratory tract, which is going to put us into the bronchi, the bronchioles, the lung tissue itself, right, main stem bronchus into the lung tissue. Those break down into the alveoli. Alveoli are the smallest structures inside your lungs. These things are really cool. Alveoli expand and contract. They're elastic type structures. So when you inhale, these things open up wide and they allow smoke, they allow air to come down inside and fill the lining of this alveoli sac. And then when you exhale, they will, as you increase pressure inside, they will push back out. These little structures here will push back out, pushing all the waste product out of our body. I mentioned smoke just a second ago because I think you need to know this, okay? And I talk with all my students about this, very important to understand. Now, when you inhale, okay, you bring in that air, this alveoli sac opens up. When this alveoli sac opens up, it accepts whatever you bring in, which may mean you're bringing in smoke, okay? That smoke is going to come down and line the inside of these alveoli sacs. It's all the tar, all the waste product that we don't actually need, that we don't want. So when you exhale, you push out waste air, right? You're pushing out some of that smoke. That tar will begin to build up, though, and this little alveoli will, over time, begin to lose its elasticity, which means it will stay wide open, big and wide open, and it cannot close anymore because of all that tar that you have built up down inside, the waste product from smoke. And this is from any smoke you bring in, because there is always a byproduct of smoke. I mean, it's got to have something left behind, right? That's what that smoke actually is consistent of. So each time you bring in air, you're actually bringing in that smoke with it, and it lines that alveoli, eventually killing the alveoli off. Now, alveoli are just like our brain cells. We have billions of them. But once they're dead, they're dead. They don't work anymore. And people, if you've seen them before in the grocery store, before, where people are walking around and they can walk a short distance and then they have to stop and take a deep breath because they just can't breathe anymore. These are people who are suffering from emphysema, okay, which is basically those elastic sacs losing their ability to contract and push back out. And here's one more thing I want you to think about, okay? Here in Southern California, we have this wonderful thing called smog, okay? So a big thing to make sure you understand is every time you inhale, whether you are inhaling smoke or just outside doing normal activities and inhaling the atmosphere outside, you are lining your alveoli with tar, because our atmosphere is already pretty messed up as it is. So if you are smoking on top of it, you're doubling your effect. It's getting that much worse, that much faster. These alveoli are very important to us. We need to take care of them. There's a story of, and I'll share right now with you, a story of a 21-year-old female who was out jogging on our beaches. And while she was out jogging on our beaches, she actually had a heart attack and died. I think it was a heart attack. I can't remember exactly what it was that caused her to die, but she died on our beaches. The big problem here, Southern California beaches, the big problem here is she had no ID on her. So they could not figure out who she was. Well, they went through the process of trying to identify who she was. And they ended up doing an autopsy on her to figure out how it was she passed away. And they recognized very quickly that she is not from Southern California. And the reason they recognized that right off the bat is her lung tissue inside was this color, pink, because she came from an area where they had cleaner air, which tells us basically, when we do autopsies on people that are raised and born and raised in California, Southern California specifically, that we have brown to black colored lungs later in our life, because we are breathing all of that junk into our lungs every single day. So the thought process here, guys, if you are smoking, you want to stop, because you're already smoking whether you are or not when you walk outside into our atmosphere. Just a little food for thought. if you guys are, curious about that. So here's all the parts, the upper and lower airway. You may see this again, kind of going over this, making sure we understand everything. Next portion of our slide is where you're going to start writing now. In those two open boxes, you're going to put down respiration. We're going to talk about inspiration, expiration, the pharynx, larynx, trachea, bronchi, alveoli, and diaphragm. So we're going to talk about all this, and I'll kind of explain what you're going to be writing down where. But basically, you're looking at the respiratory system here. Again, back to the alveoli, breaking down the smallest structures inside the lungs, which would be down inside here, and all the different parts of that respiratory system. Respiration is actually a two-phase process. It's inspiration and expiration, or inhalation and exhalation. We actually bring fresh air in, allow our body to do the thing it needs to do, and then we expel through expiration or exhalation our wasted product. When we inhale, it comes through the pharynx, the nasal and the oral pharynx, passing by cilia, which is actually meant to catch any particles that shouldn't be coming down to our respiratory tract. Obviously, it doesn't catch everything perfectly, but it does a pretty good job. So it catches all that junk that doesn't need to be there. Passes the larynx, past our epiglottis where we would swallow food, but now it's going down into the lungs itself, into the trachea, down into the bronchioles. So we've come down, from here down the trachea into the bronchioles, down into the bronchioli, okay, which then eventually get down into the alveoli, and this is where all the magic happens. So I bring in oxygen, fresh oxygen, right? And my body is now going to pull out the oxygen out of the alveoli and drop in CO2, the waste product I don't need, and then I'm going to cause the process of exhalation to push it all back out from this point all the way back through and back out of my body. So here's the thing. When I was in EMT school, I just kind of was like, maybe I don't really understand this as well as I thought. It finally kind of clicked. Maybe you know this, maybe you don't. Fact is, we breathe on what's called, and here's your first next part of the notes you're taking. Positive pressure, okay? Positive and negative pressure. We breathe off of positive and negative pressure. So when I inhale, when I breathe in, what I'm doing is I'm creating space. Inside that space is now going to be negative pressure, opposed to the outside atmosphere around me, right? So when I open that space up in my chest, air will rush into my body and fill that negative space until they equal out in pressure, and then respiration stops. Okay. I can breathe more by making my chest larger, pulling more space, but at a certain point I can't go any further and the system stops because both outside and inside pressures are equal. Now expiration happens off of the same thing, but in reverse. Now I'm going to allow my chest cavity to shrink back down in size, causing the inside to be positive, the outside to be negative. And as I push and create pressure, it pushes all the air out to a lesser pressure to eventually balance the two out. Kind of a really neat idea of the way things work. So positive and negative pressure is how we breathe. We breathe based off of creating an open space, creating a negative pressure to pull everything in till they equal out, and then creating positive pressure by adding weight, by shrinking this area up to create positive pressure as opposed to the negative pressure outside till they finally equal, and then respiration stops. So in your own words, and it's kind of a long-winded way of saying this, but in your own words, you're going to go ahead and write down your positive, negative pressure, and I kind of explained it. Next is the principal muscle of respiration, which is very important to understand. And the last one down here says diaphragm. This right here is your principal muscle of respiration. That diaphragm goes right underneath your lungs. It is the dividing muscle of your thoracic cavity and abdominal cavity. The two are completely separated by this one muscle. But this one muscle is the primary reason we breathe. Without this movement, we have a real hard time breathing. We have the rib cage, okay? We have muscle in between those rib cages called intercostal space. And those muscles can expand and contract and pull those ribs open and close them a little bit, creating some movement of the chest. But the diaphragm, when you inhale, inspiration, the diaphragm drops down. By dropping down, it pulls on the lungs, it pulls on that space and opens that space up. That creates the negative pressure inside. When you exhale, that diaphragm relaxes, turns back to its normal position, which creates pressure, shrinks that area down, creating positive pressure here, negative pressure outside, allowing it to go out. So principal muscle respiration is the diaphragm, and it's based on creating positive and negative pressure. The last one we're going to talk about is positive negative breathing. And actually, we're going to kind of reword that basically. How the reason we take a breath, okay? Please listen to me this way. So the reason we take a breath is, and as we'll reword it, the reason we take a breath is because we want to remove waste product from our body. A lot of people think that you take a breath based off of the fact that you need oxygen, and that's not true. I know it sounds really strange, okay? But the fact of the matter is, you don't breathe because you need oxygen. You breathe because you are creating waste that has to be removed. Natural removal of that means it's replaced with oxygen, which we use. So this comes down to you're either a positive breather or a negative breather. That's what we're talking about here. You guys are actually listed as negative breathers. You breathe because of an increase of CO2, not because you need oxygen. So your brainstem recognizes that your CO2 level begins to rise. How does your CO2 level rise? Your heart is beating, you're running, you're jumping, you're physically active, you are creating waste inside your system. It is burning and creating waste. And so as that system begins to recognize an increase in waste product, it has to take the trash out. So you inhale to bring in the oxygen, and then you exhale to remove the CO2 because you've just replaced oxygen and CO2 in your bloodstream. So that makes you a negative breather. It's very important you understand this, negative breather. The other side of this is the positive breather. And this is a person who is ill. This is a person who has emphysema. This is a person who has chronic bronchitis. This is a person who has something called COPD, chronic obstructive pulmonary disease. Please write that down because we're going to actually go over that again. COPD, chronic obstructive pulmonary disease. It's on your notes. So when you are considered COPD, you now are considered to be a positive breather. Your body no longer recognizes the idea that you cannot pull in oxygen, or excuse me, that your CO2, let's change that. Your body no longer recognizes that you have a decrease in or an increase in CO2. Your body now recognizes that you have a decrease in oxygen. That's why you breathe. So a positive breather breathes because they need oxygen, because they're ill, they're sick, they have some damage to their lungs. It's that COPD patient. So here's why we need to understand this. You guys are running around all day long as a negative breather, functionally working normal, no big deal. When you stop breathing for a medical reason, I've got to breathe for you. I'm just keeping that balance going. As your CO2 rises, eventually you begin breathing spontaneously on your own again because things get back into balance. But for a negative breather, excuse me, for a positive breather, COPD patient who is a positive breather, that person, if they become sick and ill, I have to be very careful about how much oxygen I actually give them. Because think of it, okay? Your brainstem, as a negative breather, tells you to breathe because of a increase in CO2, not an increase in O2. But a positive breather talks about breathing, taking a breath because you have a decrease in O2. So if I have a patient, a COPD patient, and is in need of oxygen, and I give them oxygen, it is possible I can give them too much because the brainstem recognizes that their oxygen level is not low, and the brainstem says, you know what, breathing's not necessary right now, and breathing will stop. Very important for us to understand that. That's what we really want to make sure you get out of this is we have two types of breathers. We have a positive breather and a negative breather. The positive breather is one who has been sick, has something called COPD, chronic obstructive pulmonary disease. And then we have the other side, which is a negative breather, which is a healthy, normal person just like yourself. Okay. I know this was a little unusual, a little weird. I want to make sure we get through some of this important stuff. If you have any questions, by all means, please ask. Okay. I understand it was a little bit unusual as far as lecture goes. So again, if you have any questions, please ask. Make sure you fill out those notes and turn them in when you're done. Thank you very much.